Going on, guys? It is Thursday, May 7th. We are going to get into 2.6 today. So let's take a look at our learning targets. There are going to be two of them. So the first two examples that we do are going to meet that first learning target, which is I can find the ratio of the perimeter and area of similar figures. And then example 3 is going to help us to meet the second learning target, which is I can find missing perimeters and areas of similar figures. All right, so we are still talking about similar figures, which we talked about in 2.5. Remember, that means that the corresponding side lengths are proportional. All right, so if we take a look at our first key idea, which is talking about perimeter, pretty simple. It's saying when two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. All right, so the ratio of their perimeters, so here's an example of what that looks like algebraically. So perimeter of triangle ABC over the perimeter of triangle DEF, that ratio is equivalent to corresponding side lengths ratios. All right, so AB's side length over DE, so AB, if we had this over this, that's going to be equivalent to the perimeters ratio of this triangle. And then the same thing with the rest of these. BC, if we took this number, whatever it would be, and put it over this number, whatever that would be equal to the perimeters ratio. And then same with AC and DF. So let's look at what that looks like when we have actual numbers in there. All right, again, perimeter is very simple. We're simply going to take the corresponding side lengths and we're going to make a fraction out of them. All right, that fraction we're going to simplify, and that's going to be the ratio of the perimeters as well. All right, so I'm going to take 4 since it says it wants us to go from red to blue, wants us to make our ratio from red to blue. All right, we're going to simply take 4 and put it over 6. I'm going to show you another way we can write this too. And the only thing I want to do here is I actually want to simplify this fraction. All right, so 4 over 6, both of these we could divide by 2 to make this fraction become 2/3. All right, so remember, the ratio of these side lengths, these corresponding side lengths, or the fraction of these, created fraction of these, is also the answer to the question of find the ratio of the perimeters. Okay, so the ratio of the corresponding side lengths is the exact same or is equal to the ratio of the perimeters. So simply taking these numbers and making a fraction and simplifying it. All right, so 2/3 is our answer. Now here's another way we could write a ratio. We could write it as 2 and then colon 3. Okay, so this is another way we could write a ratio. All right, and I believe that IXL is actually going to have you do that. You're going to have to write it like this when you work on that tomorrow. All right, so take a look at that one more time and just see what the book does. So they're just saying, guys, that the perimeter of the red rectangle over perimeter of the blue rectangle is equal to these corresponding side lengths at the ratio of the corresponding side lengths. Okay, so they put 4 over 6 and they simplified to 2/3. All right, so simple as that when we're talking about perimeter. All right, so let's try another one. It's saying find the ratio from red to blue of the perimeters of these two trapezoids. Okay, so because we're talking about perimeters, we are simply going to look. Here's red is 21. This corresponding side length to this corresponding side length is 15. So I'm simply going to make a fraction out of those. So 21 over 15. I'm going from red to blue, remember, because that's what it asked me to do. And now I'm going to simplify these again like I did in the last problem. 21 and 15, we could divide both of those numbers by 3. Okay, so our simplified answer, 21 divided by 3 gives me 7, and 15 divided by 3 gives me 5. So this is my final answer here. All right, so again, for perimeter, it's as simple as finding corresponding side lengths and making a simplified fraction out of them to find the ratio of the perimeters. Okay? All right. So I'm going to have you guys give this a shot. It says the height of figure A is 9 feet, so it doesn't have a picture this time. So the height of figure A is 9 feet. The height of a similar figure B is 15. What is the ratio of perimeter A to perimeter B? All right, so same concept of what we just did. Let's make a fraction out of those corresponding side lengths and just simplify it. All right, so why don't you get an answer, and then when you come back, after you pause your video, come back, the answer will be up. All right, so again, it's asking us to go from figure A to figure B. All right, so we're simply going, all right, 9 over 15. And again, both of these numbers are divisible by 3, right? So if we divide 3, that's where we're getting. That's where we're getting this answer of 3/5. Okay, so perimeter is as simple as that. Now we're going to talk about area, where we're going to do a very similar concept. All right, but because it's area, we're going to square that fraction. All right, we actually somewhat talked about this in chapter 9. I don't know if you remember, but we did this in class. We did it with surface area though. Now we're just talking about regular area. All right, so the next key idea is, now that we're talking about the areas of similar figures, when two figures are similar, the ratio of their areas is equal to the square of the ratio of their corresponding side lengths. All right, so it's just like perimeter. We're going to take corresponding side lengths and make a fraction and simplify that fraction, but then we're going to square it. Okay, and we're going to square that fraction. That's going to give us our ratio of our areas. As you can see here, they have that same kind of diagram where the area of the triangles is equal to the corresponding side lengths fraction, but squared, okay, on each of these. All right, so let's try this one. All right, so again, we have to make sure we're reading correctly. So find the ratio. We're going from red to blue again of now the areas. All right, so the only difference going from red to blue, so 6 over 10. I'm going to do the same thing. I'm going to simplify this right away. Okay, so I could divide these both by 2 and simplify this to 3/5. All right, so if it was talking about perimeter, right, this would be our answer. But now it's talking about area. So I'm going to take this fraction and square it, top and bottom. All right, so 3 to the second power. 3 to the second power is 9. And 5 to the second power is 25. So here's my answer for the area. Remember, if it asked for perimeter, it would have been 3/5. But now that we're talking about the ratio of the areas, we're going to square that fraction. All right, and that's the only difference. That's the only difference. Let's take a look. Now the book does the same thing. They're taking area of red over area of blue is going to be equivalent to their corresponding side lengths to the second power. They simplified the fraction first, okay, to get 9 over 25 as well. All right. Now let me show you something else real quick. We could do it this way too. We could simplify after we square. So like we could have taken this fraction and squared it. So 6 squared is 36. And 10 squared is 100. But then both of these numbers, we could divide by 4 and simplify it. Okay, so we could simplify after, and that would have given us our 9/25. But I will give you kind of a hint here. It's much easier to simplify first, okay, because these numbers, simplifying these numbers, are much easier numbers to simplify than simplifying these numbers, much higher numbers. Okay, so I would suggest only simplifying first before you square. All right, let's try another one. So again, find the ratio. We're going red to blue of the areas, okay, of the areas. So I'm going to take this and this, corresponding side lengths. I'm going to make a fraction out of them. So I got 9 over 6 right now. Okay, I'm going to simplify that fraction. I can divide both of these by 3. and that's going to give me, I'm going to go down here, that's going to give me 3 over 2. Now the difference between this and perimeter is I need to square that, okay, to get my final answer. So 3 squared gives me 9, and 2 squared gives me 4. So this is my final answer here. This is my ratio of my areas of these two parallelograms. All right. All right. So let's talk about why are we doing this? Why is this important? Because we're going to now use these fractions as base fractions to find actual missing perimeters and missing areas of shapes. Okay. So if we know their ratio, we can find the actual perimeter and area of specific shapes, which is exactly what we're going to do in example 3. And mainly what you guys are going to be doing in your practice and in your IXL. All right. So this is going to help us to meet that second learning target. Okay. So we're going to need to use those ratios to do this. So I can find missing perimeters and areas. All right. So if we can use those ratios, we can find those missing areas and perimeters. All right. So example 3 is saying a swimming pool is similar in shape to a volleyball court. Find the perimeter and the area of the pool. All right. So here's what we're going to do. We're going to first create ratios of the perimeters and the areas, and we're going to use them as base fractions, okay, to find the pool's perimeter and area. If you look down here, we have some information down here. We know the volleyball court's area and perimeter. Okay. So first things first, let's make ratios. And we can do this either way we want. I'm going to make a fraction from the volleyball court's corresponding side to the pool's corresponding side. So I'm just going smaller to larger. Okay, so I'm going to go 10 over 18. All right, and I'm doing the perimeters ratio right now. Okay, so 10 over 18. These numbers are divisible by 2. So I'm going to simplify it to give me 5 over 9. Okay, so this is the ratio. This is the ratio of the perimeters of these two similar figures. Now, I know the perimeter. I know the perimeter of the volleyball court. Remember, when I did my ratio, my volleyball court was on top. Okay, so what I'm going to do is I'm going to write a proportion, which we've done as well in class, saying, here's the perimeter that I know, and let's call this X. This is the perimeter I'm looking for. Okay, so remember, volleyball court over pool, volleyball court over pool, and now I can cross multiply to solve this proportion. All right, remember their corresponding side lengths are proportional, and their perimeters are proportional in their areas. Okay, so I can use this method to solve this. So let's take a look and see that the book does the same thing. All right. So again, it says the rectangular pool and the court are similar, so use the ratio of corresponding side lengths to write and solve proportions. All right, the first one we started with was the perimeter. They did the same thing. They went from court to pool. All right, so they didn't even simplify their fraction, which I did, but remember, guys, it'll still give you the same answer no matter what you do. All right, but they cross-multiplied here. They cross-multiplied here to get these numbers, and then they divide to find the perimeter would be 108. All right, now let's look at the area. I'm going to do the same thing with area. Okay, so remember, same fraction. I'm going to make my fraction back into my simplified fraction, which was 5/9. But since I'm finding the area now, right, it's saying we have to take the width of the court and the width of the pool and square that. Okay, to get my base fraction this time, I have to square first. So 5 squared, I'm going to come down here. That's going to give me 25. And 9 squared is going to give me 81. Okay, now I'm going to make a proportion using this as my base fraction. The area of the court is 200, Remember, I put the court on top. So I'm going to put court on top again, and then I'm finding the area of the pool. So X. All right, so I'm going to use my calculator this time and show my work. So 81, I'm cross multiplying, right? I'm going to cross multiply. 81 times 200 in my calculator gives me 16,200. Okay, so I'm going to come over here. 16,200. And I'm going to set that equal to 25 times x is 25x. Okay, now how do I solve for x? We are going to divide by 25. Divide by 25. All right, so 16,200 divided by 25 is equal to 648. So my area is equal to 648. Okay, so hopefully that makes sense. It's a bit confusing. Let's erase this and show the book. All right, so again, if you look, they just square the original fraction of 10 over 18. They didn't simplify, but remember what I said? It doesn't really matter, okay? It's kind of up to you. I always like to simplify though, all right? But you're cross multiplying, you're setting up a proportion, and then you're cross multiplying to solve, all right? So we're going to do the extra example, so I can just show you this one more time because it is a little confusing. And the extra example is just changing one thing. It's saying, actually, let's do the on your own question. We're just going to do it together. It's saying now the width of the pool is 16 yards instead of 18. So let's find the perimeter and area. Okay, so the only thing changing is the width of the pool is now 16. All right. The width of the pool originally in the last problem was 18. All right, so if we're doing perimeter again, what I'm going to do is I'm going to go from volleyball court to pool again. So the volleyball court's width was 10. The pool's width is now 16. All right, so that's going to change my answer a little bit. Okay, so I'm going to simplify this. I'm going to divide these both by 2 to give me 5 over 8. Okay, so this is the ratio of the perimeters. I'm going to set that equal to the perimeter of the court was 60. And we're finding the perimeter of the pool. Okay, so again, I just get my base fraction for my perimeter by making a fraction out of corresponding side lengths. Now I'm going to cross multiply to get 5x equals 6 times 8 is 48 plus the 0, so 480. Okay, and now how do I solve for x? We're going to divide by 5 on both sides to give me my perimeter equals 480 divided by 5 gives me 96. Okay, so there's your perimeter answer for the pool with these dimensions now. All right, now I'm going to do the same thing with area. So if I'm finding area, right, I'm going to take this same fraction, I'm going to simplify it again, the 5/8. But since I'm looking for an area now, I'm going to square that first. I have to do this. Okay, so 5 squared gives me 25. 8 squared gives me 64. I'm going to use that as my base fraction now for my proportion. The area in the last problem of the court was 200, and I'm finding the pool's area. Okay, so same thing, cross multiply. So 25x equals 200 times 64. That gives me 12,800. 12,800. and I'm just going to divide by 25. $12,800 divided by 25, that's going to give me 512. Okay, so my area of my pool would be 512. All right, so there's all the work. Let's check our work. All right, so 96 yards for perimeter, okay, and 512 yards squared for area. All right, so that's the end of it. Hopefully that made sense. If not, please ask questions. Please email me to ask questions or ask in your discussion thread. But right now you're just going to complete some practice problems and big ideas under 2.6 practice. Okay. Again, ask questions if you have them. But otherwise, I'll talk to you guys tomorrow.